everyone. Today I will showing the retaining wall steam design. There is the steam part. Steam part is only upper portion and lower portion is the base. Here is called base. We will not discuss the base portion today. Rather we will discuss design the steam design. Okay, let's start. At first, read the question. Uh, an artificial lake is constructed with a reinforcement concrete cantilever retaining wall is shown figure. Here is the figure. Below the soil, beside on wall is saturated water. Here is the saturated water, and gamma soil is 118 pound per feet cube, and the friction of angle of 0.30, and the height of the cantilever by cantilever retaining wall is 20 feet, and design the steam. Here is the steam, and the optimum thickness of bending moment, and we have to design the thickness of the steam. Here is the thickness, and they assume the record data is designed as per ACI code, and basic depth of the basic span depth ratio of cantilever is set. Okay, let's start. So at first the coefficient active pressure of soil, which is 1 minus sin phi divided by 1 by sin phi, and 1.33, and the pressure of horizontal, here is the pressure of horizontal, is gamma prime is. Gamma prime will be 118 deduct or minus 62.5. So 62.5 is mainly the water, so we will deduct the pore rotor pressure from here. That's why we will deduct the 62.5 and found 366.5, which is feet per pound per feet cubes. And now we will consider 1 feet of the steep. That's why we have found feet per pound per feet, which is called UDL. Now we will find the design load, which is 1.2 dead load plus 1.6 live load. The live load is already I have found 366.3. On the other hand, we will see the live load. Live load actually comes from the water. When we will design the dam, in the larger dam, so we can see that there is no soil or on the side of the dam. That's in that case we have considered the water is a live load. So in this case there is no water, free water. That's why the live load is 0. Okay, the design load is 0.4 kg per feet we have found here. The analysis here is we have found the force. I have already written the R. It will be force. The force will be half into length. Here is the length and height. The area of the triangle is over the force. So half it into length 0.44 I have found, and height is 20 feet is given in question. That's why 4.44, and we will take the moment at the bottom of the bottom of the steam. That's why we have multiply 1/3 into each. The reaction force has situated 1/3 of H into R. On the other hand, if we calculate the from top portion, then it will be 2, but we have calculated from the bottom. That's why we have found 1/3 H. Okay, 29.33. This is our moment. So we will design for this moment. They assume the depth of steam is by 8, which is 30 inch. The 8 by 8 I have found in Nadim's books, RCC designed by Nadim. You can search on YouTube, then Google, then you have found the references, which is 8 by 8. So 30 inch, that means this is the depth of 30 inch, not the base depth. We have designed the steam. That's why this is the 30 inches. Now we'll check this depth. At first we use flexible check. The flexible check is here. We can see that there is a two triangle. One is bigger triangle B max divided by H, B max divided by 8, And another one we have shown, which is a small triangle, which is called BD divided by H minus D. This is the small triangle. So we will compare this triangle, small triangle divided by small big triangle into small triangle, and we have found the BT. BT means the share at the depth at the point of T, which is 0.385 kip, and the capacity of the share, which is 5 BC, equal to 25 into by reference B D. Here is the B value is 1 feet or 12 inches and found 29.57. We have seen the resisting shear is 29 is greater than the induced shear, which is 0.355. So we can see the depth is okay. We have already at first we assumed the 30, that's why we can say the depth is okay. Now we will see the design the vertical reinforcement. So vertical reinforcement, I have found the formula as 0.85 FNC Fy 1 minus root over 1 minus 2m phi 0.85 cd square d into d. This is this formula taken from Dr. Reported Professor Dr. Iftikhar Anam sir, which is a professor of University of Asia Pacific, and found the 0.22 inch square per feet. On the other hand, we can use the conventional method, or this formula as Fy divided 0.FNC B and found 0.19 as, and putting this value here, m divided by 0.F9 d minus a. Here is the a value in 0.19 as, and found as 0.22 inch square. So 0.22 inch square and here the 0.22 inch square, all the value are same. If we use this formula, or you can use this formula, we shall use this formula for as a conventional method we have seen. And now we have seen the minimum reinforcement, which is 200 divided by FYBD, and found 1.2 inch square. So we have found two value, which is 0.22 inch square and 1.2 inch square. So we will take the bigger value for the taking the safe zone, and we have used 1.2 inch square to be used. Now we are using 8 number bar. The area of 8 number bar is 0.89 inch square. So number of bar 1.52 per feet does not need this line. Now spacing will be as b divided by as. So we have shown 0.89 inch square center to center. So 8 number is vertically placed. So this is the vertically bar. This is the vertically bar. So we have placed number 8.789 inch square center to center. Horizontal bar, we have used the minimum reinforcement. Here is the horizontal bar I have shown here. Horizontal bar I have shown here. So horizontal bar will be minimum reinforcement. We have already found here minimum reinforcement by 1.2 inch square, which is number 8 number by the rate of 0.789 center to center horizontal place. So in the temperature, on the other hand, the temperature bar, I have found the another sources. So its temperature bar is 0.36 into thickness or depth. We can say here 30 inch square. Here is the 30. So we have found 1.08 inch square. So spacing will be 8.7 square. So this is the temperature or shrinkage bar. We shall use this. I am changing the color here. The minimum reinforcement bar we can use here for temperature or shrinkage bar. The both transverse or vertical or horizontal bar, we can use this bar for from this formula 0.03 into T or D, what we can say. So this is our steam design of the retaining wall. So I can conclude I can summarize that. At first we can found the active pressure coefficient of active, then active pressure, then pressure horizontal, and the force has converted here one strip and design 1.2 dead load, and found the force which is the area of the triangle we can call the force, and the moment is acting from the bottom, which is 1/3 into force, and found this moment we will design, and they assume their depth is 30 inch, and check this depth by shear, which is resisting shear is 29, but we have induced shear 0.38, so the depth is okay. And then we have used this formula, or this formula we will use as Fy. This formula is recommended depth, and found 0.22 inch square, and the minimum reinforcement 1.2. So there are 2.212 inch square is governed as the bigger reinforcement found, and we have used number 8 bar and the spacing concept. The vertically bar as found from this moment. So this is the vertically bar we have used from the moment. On the other hand, horizontal bar, we can use the minimum reinforcement. The horizontal bar, here is the horizontal bar are designed from minimum reinforcement. On the other hand, the opposite side, where is no support, no water, nothing is here. We can see the figure. The left side, there is no water, no soil. We shall use here the minimum reinforcement or temperature bar 0.1 360, which is 0.13, and we can use number 8 bar 1 at the rate of 8.76 center per cent. So this is the steam design. So if you have any question, let me know. I will try to explain you. Thank you everyone.